The Sandy Fire in Simi Valley rapidly became one of the most dangerous wildfire incidents of the season, burning hundreds of acres, threatening homes, and forcing firefighters to shift from direct suppression to large-scale containment strategies. The fire revealed how extreme terrain, unstable winds, and heavy fuel loads can quickly overwhelm traditional firefighting methods. How did the Sandy Fire spread so quickly? The fire spread rapidly because of dry chaparral vegetation, steep canyon terrain, and changing winds. As flames moved uphill through narrow canyons, heat and airflow intensified, accelerating the fire and carrying embers far ahead of the main front. Why did early firefighting efforts fail? Ground crews initially used handlines and bulldozers to stop the fire, but extreme heat and heavy ember showers caused spot fires beyond containment lines. Conditions became too dangerous for direct engagement as visibility dropped and flames intensified. What made Sandy Canyon especially dangerous? The canyon created a Venturi effect where compressed airflow increased wind speed. This accelerated ember transport, intensified oxygen flow to the flames, and caused unpredictable fire behavior across the ridges. When did firefighters change strategy? The strategy changed once multiple spot fires formed and crews could no longer safely hold the fire line. Firefighters shifted focus from direct suppression to protecting structures and building larger containment zones. How were aircraft used during the operation? Heavy air tankers and helicopters dropped retardants and water along ridges, roads, and threatened areas. Their goal was not to fully extinguish the fire but to slow its spread and support ground crews. Why are fire retardants important during major wildfires? Fire retardants slow combustion by coating vegetation and reducing ignition potential. Unlike water, retardants continue working after evaporation and help create defensive barriers ahead of advancing flames. How do gel suppressants differ from water drops? Gel suppressants cling to vegetation and structures longer than water and resist evaporation under extreme heat. They provide stronger protection in high-temperature zones where ordinary water evaporates rapidly. What is backburning and why was it necessary? Backburning involves intentionally burning vegetation ahead of the wildfire to remove available fuel. Firefighters used this tactic to create defensive zones that slowed the fire's horizontal spread and stabilized containment lines. Why is communication critical during wildfire emergencies? Modern wildfire response depends on real-time coordination between ground crews, pilots, weather analysts, and command centers. Fast communication helps prevent entrapments, improves evacuations, and increases suppression efficiency. What environmental impacts can chemical drops cause? Large-scale retardant use can affect soil chemistry, waterways, and local ecosystems. Despite these risks, agencies often consider the environmental impact acceptable compared to the destruction caused by uncontrolled wildfires. What lessons were learned from the Sandy Fire? The fire demonstrated the growing importance of aerial coordination, advanced weather tracking, fuel management, and predictive technology. Future wildfire strategies will likely rely more heavily on drones, thermal mapping, AI forecasting, and expanded prescribed burns. Finally, the Sandy Fire showed how modern wildfires can rapidly evolve into atmosphere-driven disasters capable of overpowering traditional firefighting methods. The incident highlighted the importance of technology, coordinated response systems, and adaptive containment strategies in protecting lives and communities during extreme wildfire events. If you enjoyed this educational analysis, remember to like the video, share it with others interested in wildfire science and emergency response, and subscribe to the channel for more detailed documentaries and disaster investigations.